So this video is for my geometry class. This will cover section 7.3 homework. It's the homework assignment, but it's just for practice that we've done in class to cover what we've learned so far from the section on the Pythagorean theorem. So I've got the assignment at the top, and if you do not have this worksheet, then I will have emailed it to you along with the link to this video. So let's go ahead and get started. So remember, with the Pythagorean theorem, we are, let me fix the size of this thing, hold on. We're going to be finding the lengths using the Pythagorean theorem, and then I'll show you how that applies to the area that we've learned in previous sections, or calculating area. So for this first one, you can see that we have a right triangle and they've given us the hypotenuse and one of the legs. So going back to the base Pythagorean theorem, it's a squared plus b squared equals c squared. And the sides that are connected to that right angle, these are your legs. So that's your A and your B. That's a leg, and then here's your hypotenuse. That's going to be that opposite the right angle. So that's how you know where to put everything. I'm going to go ahead and put my x squared for my A plus 12 squared for B equals c squared, which is my hypotenuse. And then let's go ahead and simplify this down. X squared plus 144 equals 169. So I'm going to go ahead and subtract this, 144. And so we get x squared equals, I believe that's 25. All right, I'm running out of the little, y'all should have plenty of room kind of to the right of this. I'm just going to move this up here. So we know we've got to get that x squared, the exponent off the x. So we square root both sides. These cancel out, so then we're left with x. Well, we also know 25 is a perfect square. The square root of 25 is 5. So we now have the length of that leg. So x equals 5 centimeters, and we're done. Just an easy, quick review using the Pythagorean theorem. So let's go and move on. These kind of get more difficult as we go on. So for this next one, we have 3 inches and 5 inches. Those are the two legs. So now we're finding the hypotenuse. So I'm going to write that, let's see, hopefully I don't make too big of a mess. Let's do it this way. So I'm going to write it with the hypotenuse first. D squared equals 3 squared plus 5 squared. So D squared is 9 plus 25. Whoops, that's what happened. Here we go. And so we just continue to simplify. That's 34. So now the square root of both sides. Now 34 is just, when you break that down into its prime factorization, you find it's just 2 times 17. So we can't simplify this anymore. So we end up with D equals the square root, of 34. And if you plug that into your calculator, actually, let me go and see if I can switch my share here. Let's go and plug that into the calculator. Hopefully you can see this. Each one is a little bit different. I believe for mine, I have to put the number in first. So I have 34, and then I hit my square root button. Of course, these are irrational numbers. They go on to infinity, but just keep the first decimal place, round to the first decimal place. In this case, we would leave the 8 the same. So this is approximately 5, and I lost my number. Let's see. Uh-oh, looks like I lost everything. Let's see, 5.8. Okay, let's go back. All right, so 5.8, and this one is in inches. Don't forget your units. So approximately 5.8 inches, or you could give me square root of 34 inches. Works too. All right, let's go ahead and move on through. Okay, so for this one, we have our 2 legs. One is the square root of 3, one is the square root of 2. So it's quite easy. So y is my hypotenuse. So again, I'm going to leave that, start with that on the left, equals the square root of 3 squared plus the square root of 2 squared. And again, it doesn't really matter if you have a square inside the square root or outside, they still cancel each other out. So these two actually just cancel, and you end up with y squared equals 3 plus 2, which is 5. So y squared equals 5, but we do still have to find the square root of both. And that just means that y equals 5 is prime. So we can't do anything else with that. And so we get that as our answer. And if you put that into your calculator, you'll find that that equals 2 point, okay, that equals 2.2, and this is feet, approximately 2.2 feet. Hopefully, easy enough. Honestly, using the formula is the easiest part. It's getting the reintroduction to your square roots and how we simplify those that I feel like can be the most complicated. So let's go ahead and keep moving on. So in this case, now it's a leg that we're having to find, a. So a squared plus my b squared, I'll have that as the 5, equals 10 squared. We continue to just simplify. That's 25, that's 100. When we subtract the 25 from both sides, we get a squared equals 75. So then we go ahead and square root both of these. Those will cancel out, and a equals the square root of 75. Now, this does simplify. You should know, just from like the way that our money works, is that 3/4 makes 75 cents, and 25 cents is 5 squared. So I'm going to go ahead and separate this into its prime factorization, 5 squared times 3. And then the square root and the squared cancel each other out, and that 5 comes out of the square root. A equals 5 square root of 3, which when you plug it into a calculator gives you 8.7, and then our units is meters. So you can give that to me anyway, 5 times the square root of 3, or approximately 8.7 meters. Obviously, solving those, we don't really keep in our heads the square root of numbers that aren't perfect squares. So it's good to plug it into a calculator and go ahead and get an idea, because I certainly know more about the length of 8.7 meters than I do 5 and the square root of 3 meters. No idea. Okay, excuse me. All right, so let's go ahead and move on. Number 5, we have a leg and a hypotenuse. So I'm going to go ahead and start with my z. Leg plus leg squared equals 7 square root of 2 squared. All right, and again, this is a nice review because you can think of this as, you could use the distributive property. So this is sort of like the square root of 2 squared and 7 squared. So we know that z squared plus 49 equals, well, 7 squared is also 49, and then the square root of 2 squared is 2. It cancels out. So this is like 49 times 2, and that would be 86. So I'm going to subtract, I said 86, making up numbers now. 98, 49 times 2 is 98. But I'm going to subtract the 49. So instead of having two 49s now, we just have one. So z squared equals 49. So you know what I'm talking about. That's essentially all I've just done. And we know 49 is a perfect square because we just did it. So this is z equals 7. And these are our units. So this one is nice and even. This actually will play a part into what we're going to learn in the next section with the special kinds of right triangles. But we'll get into that then. All right, let's go ahead and move on. Let's practice square roots with decimals. All right, so again, this case, D is a leg. So I'm going to go ahead and put it first, plus 0.5 squared equals 1.3 squared. All right, and you have to be really careful. You remember that 0.5 squared is 0.5 times 0.5. So you have 2 digits after the decimal. So this actually gives you 0.25. Same thing with 1.3. D squared plus 0. And also think of it, 0.5 is half. So what's half of a half? Well, it's a fourth or a quarter, which is what 0.25 is. All right, so this one changes into 0.25. And then we know that 13 squared is 169, but we're going to have two decimals. So it's 1.69. All right, so now let's go ahead and just finish this 0.25. D squared equals, that's a 4, that's a 4, here we go, 1.44. Well, that we know 144 is a perfect square because it's 12 times 12. However, because of that decimal, we need to make sure that we write that 12 as 1.2, which is our final answer. So in this case, we have another nice, neat answer. So 1.2 miles is our the length of that leg. All right, this next one is more kind of an abstract theory. It's practice on the, just to make sure you understand how to manipulate the Pythagorean theorem, the Pythagorean formula, into whatever way that you need to. So in this case, they're telling us to write an algebraic expression. So this means we're not going to have a final numerical answer. We're going to have a expression with variables and constants. So we want to give the expression for the other leg of a right triangle that has a hypotenuse of 9 and a leg of y. There's that other variable. We don't know what that is. So I'm going to go ahead. My hypotenuse is 9. I'm going to use x for my unknown. This is my unknown leg. And then y is the one that they gave me. So I know one is y, the other one is 9. So we're going to solve for x. So we would write this in the base formula as x squared plus y squared equals 9 squared. I'm going to go ahead and simplify it. I don't know why I made this so narrow. I certainly need a little more room. I'm going to go, it's 81. And let me go ahead and move back over this way. I do need to subtract that y squared from both sides. So my answer is going to be x squared equals 81 minus y squared. And then, just like we always do, we get the x by itself. And so our final expression for that second leg is the square root of 81 minus y squared. And so that's the answer that we're looking for here. So this algebraic expression, square root of 81 minus y squared, is a representation of the length of that leg in this right triangle. So if they gave us a value for y, we could plug it in and solve for x. All right, so let's go ahead and move on. This is the last thing that we talked about in section 7.5. So in this case, you can use the combination of the triangle inequality theorem and the Pythagorean theorem to determine what the shape of a triangle is going to take. So what we do is, first, we've got to decide, can a triangle exist with sides of this length? That's where the triangle the inequality theorem comes into place. So first we have to figure out, does this triangle exist? Is it possible? Or is it going to make, something like this, where it just doesn't finish? All right, so first we have to figure out what the square root of 5 is. Well, the square root of 5, as we learned earlier in a previous problem, is around 2.2. So if this were a right triangle, that would be your hypotenuse. The hypotenuse has to be longer than either of the other two sides in a triangle. That also means with the triangle inequality theorem is that the other two sides added together, so 1 plus 2, must be greater than the longest side. So we always check that first. In this case, 3 is definitely greater than 2.2. So yes, this is these are possible lengths for a triangle. Now we just have to figure out what shape that triangle is going to take, whether it's a right triangle, which means that these would equal, whether it's acute or obtuse. So this is where the Pythagorean theorem comes in. So obviously my two legs are the length of 2 and the length of 1. So This is going to be 2 squared plus 1 squared equals the square root of 5 squared. Now, if this makes a true statement, then we have a right triangle, right? Because the Pythagorean theorem tells us that if the sum of the legs, the two shorter sides, squared, I said that wrong, but the sum of the squares equals the hypotenuse squared, then you have a perfect right triangle. So let's go ahead and solve this and see what we get. 2 squared is 4. 1 times 1 is just 1. And of course, the square root and the square here cancel. This is 5. Well, 4 plus 1 does indeed equal 5. So we have a right triangle. And the last part here, explain your reasoning, is pretty much what I just wrote. 4 plus 1 equals 5. That's our proof that this is a right. The sum of the squares of the legs equals the square of the hypotenuse. All right, so let's go ahead and look at this next one. I've got 5 inches, 12 inches, 14 inches. Well, 14 is my longest. So does it exist? Let's see. Is 14, I keep doing these back. I do them different every time. Let me try to be consistent. Are the legs 5 and 12 added together greater than the third side? And in this case, they are. 17 is indeed greater than 14. So this is a valid length for the sides of a triangle. So now let's check and see what the Pythagorean theorem tells us. So 5 squared plus 12 squared, if 14 is indeed, or if this is indeed a right triangle, then the sum of these would equal 14. If 14 is greater than, that means that we have an obtuse triangle, and if it's less than the sum of the squares of the legs, then it would have to be an acute triangle. So 25 plus 144 equals 196. 25 plus 144 is 169. 96. So they do not equal. And in fact, the sum of the leg of the two shorter sides is less than, the sum of the squares of the two shorter sides is less than the square of the longest side. So this must be an obtuse. That angle, where normally you would have a right angle, is going to be greater than 90 degrees. And this is because 25 plus 144 is less than 196. All right. So now we're back to looking at different shaped polygons and finding the right triangles within them. I don't know why I can't draw straight anything. There we go. All right, so if we have a rectangle, draw a diagonal through it. They want to know what the length of that diagonal is. Well, the nice thing about a rectangle is all of its interior angles are right angles. So we can use that diagonal to create a right triangle, which makes our Pythagorean theorem useful. So the 4 meters and the 12 meters are my legs. So 4 squared plus 12 squared equals x squared. So 16 plus 144 is x squared. Go ahead and continue to simplify. 160 equals x squared. So now we have to find the square root of both of these. And we end up with, I'm going to go and flip it as well, x equals the square root of 160. Now, this is the part where you guys are going to need to be able to simplify these radicals. So when I look at 160, I can see instantly that there is a perfect square in there. So let's look at this. I'll do a different color. So if I look at 160, I can separate that into 16 times 10. And 16 is a perfect square. This is 4 squared. Now 10 is made up of 5 and 2, both of which are prime numbers. So we can't pull anything else out of that, any other perfect squares. So that's going to stay underneath. But this 4, that squared exponent is going to cancel out with square root. So the 4 comes out, the 10 stays in, and we have, and this is in meters, we now have the length of the diagonal. It is 4 square root of 10 meters. Did I? Nope. I didn't calculate the actual value of that, the approximate value of that, probably around maybe 3.2, something like that. So it's probably around 12 something meters. But anyway, let's go ahead and move on. So this next section is where we use the Pythagorean theorem to determine the height of a polygon. And then once we know that, we can use that height to calculate the actual area of that polygon. So the important thing about this is this 10 feet right here is the entire side of this triangle. They're just giving us the 3 feet because we need this part here, 7 feet. My phone's blowing up. Okay, so anyway, so the 10 feet is the whole triangle. However, you can see we have a height here that we have to calculate, and we have to use this left half of the main triangle because that we have the length of that hypotenuse and one of the legs. So that's the side we're going to have to use in order to figure out what that height is. So let's start with that first. Okay, it's a leg. So height squared plus 7 squared. If you don't mind, I'm going to go ahead. I think we understand this at this point. I'm going to go and write down the square, and then 8 squared is 64. So I'm going to subtract the 49 from both sides, and height squared is, what is that, 15? All right, well, 15 is just 3 times 5, so that's not going to give me any, I can't simplify that. So the height of this triangle is the square root of 15, whatever that may be. All right, but I can still plug that in. So if I'm finding the area of a triangle is the base times the height divided by 2. This is where the 10 feet is also very important because the base of the whole triangle is 10 feet. You have to use that for the base when finding the area. So I'm going to go ahead and plug that in. So that's 10. And then the height I know is the square root of 15. So I'm going to go ahead and cancel out this 10. 2 goes into 10 5 times. So that gets rid of my fraction. So I have the area as 5 times the square root of 15. And I believe I did calculate that. Let me see. Yeah, so that square root of 15, it's somewhere around, I think, probably 3.8 or so. And so when you multiply those, I was going to show you with a calculator, but it differs based on the different calculator. Anyway, it ends up in being 19.4 feet squared. Again, remember, we're calculating area, so square your units. So approximately 19.4 feet. All right, let's keep going. So for this one, we have this tiny little right triangle here where I have the, of course, I can't do anything straight, but you know what I'm talking about here. I need to figure out this side, which is a leg. They gave me the hypotenuse. So first, let's figure out our height. Height squared plus 25, that's my 5 squared, equals 144. That's my 12 squared, my hypotenuse. I'm going to subtract the 25. And h squared equals, let's see, that's 9. That's 119. 119 definitely doesn't have any perfect squares in it. It's most likely a prime number. So the height equals the square root of 119. Now, here's the important part. Remember, with a with a parallelogram, it's essentially like a crooked rectangle. So the whole base is the 15 meters. They just gave me the part that I needed in order to calculate my height. But that whole base is 15. So this is 15 times the height, which is 119. So let's go ahead and plug that in to find area. So the area of a parallelogram is the base times the height. So this is the base, which is 15, times the height, which is 119. And when you plug that into a calculator, you get the approximate area of 163.6, and this is meters squared. All right, so there's our answer. Approximately 163.6. If you do leave it in the sorry, with the square root in radical form, which technically is covers the irrational number, so it's not an approximation, then you must absolutely make sure that you have reduced that radical as far as you can. So the other option is to plug it into a calculator, and I will also take the approximate, and that saves you from having to reduce it. All right, let's go ahead. That note made. Get it to behave. Okay. All right, so let's look at the next. Now, this next one is a trapezoid. So first we can use this left side here. We have a right triangle, we have a hypotenuse and a leg. So this we can use to find our height. So height squared plus 9 squared, which is 81, equals 12, which is 144. 1, 1 minus 1 is 3, 14 minus 8 is 6. And the height squared equals 63. So the square root of that, we can pull out a perfect square here. 63 is 9 times 7, and 9 is 3 squared. So the height is, what, 3 square root of 7. All right, so once I have the height, we need to go to our area. So the area of a trapezoid, if you remember, is 1/2 of the base, the height times the bases added together. So in this case, my entire bottom base, 25 plus 9, is 34. So this, we got to add these together, get the whole thing. This is 34 plus 18. Oh, and sorry. Let me just write the base formula first. It's height times base divided by height times the bases added together, divided by 2. Okay, so my height was some crazy 3 square root of 7, and I just figured out the base is 34 plus 18. All that's divided by 2. So the 34 plus 18 is going to give me an even number. So I'm actually going to keep 3 square root of 7. I'm going to put that inside parentheses. And then 34 plus 8 is 12. Carry my 1, 3, 4, 52. Divided by 2. So 2 goes into 52 26 times. So here's where we continue our learning with these radicals. So this is 26 times 3. I'm also going to split these up. Times 3 times the square root of 7. Well, I can combine the 26 and the 3. 26 times 3, I don't know what it is. 6 times 3 is 8, carry 9. 1. So 78 square root of 7 centimeters squared. So there's the exact answer with the square root. And when you plug that into a calculator, I'll put it up on the bar. You get 206.4 centimeters squared. That's the approximate answer. All right, moving on. For this last one, we have a triangle, and the nice thing about this one is it is equilateral. So when we draw so the altitude actually is a perpendicular bisector. They're the same. And so what that does is, because they're all exactly the same length on each side, when you draw the altitude down to the base of this one, then you create a right triangle, and it's going to occur exactly at the midpoint. So that tells you that the side is, each side of that is 2.5 yards. So now I can calculate that height based on one of these right triangles using the Pythagorean theorem, and then in turn can find the area of the entire triangle. So starting with the height is the is that middle line. So it's leg. So h squared plus 2.5 squared equals 5 squared, which is 25. So again, 2.5 squared, that's like 25 times 25, but you have to move the decimal place, the decimal 2 places. So height squared, 25, 25. I think that's 675. 5.2, 5, yeah, 4. Wait, that's great. Okay, so 5, 7, so 6, and there's a decimal, so 6.75. 6.75, 25, some zeros. So I can subtract. You know, I did that too fast. Hold on. Let's do this again. 2 times 5 is 10. Sorry, my line. So, sorry, that is 6.25. All right, sorry, 6.25 h squared equals, I know that's going to be borrow, so 4 minus 6, 14 minus 6 is 8, so 18.75. Okay, and then we square it, 18.75. So I am sure 25, let's see, 25 times 25 goes into 1,875. So I think when I do the math on that, I actually end up with h equals the square root of, this would take care of my decimals too, 2.5 squared times 3. So the 2.5 comes out, and I end up with the height as 2.5 square root of 3. So there's the height, lovely number. Decimals and square roots all around. But we can go ahead and just plug that in and see if we can, anything simplifies. So for this one, the area of a triangle is the base times the height divided by 2. So if I plug in the base, and I remember you've got to use the base of the whole triangle. We're finding the area of the whole triangle now. So we don't need the 2.5 anymore. It's 5 yards. So this is 5 times 2.5 square root of 3 divided by 2. All right. So here's a little bit of a trick that I hope won't be too terribly confusing, but I really want to get rid of both the decimal, if I can, and the fraction. Now, with a fraction, just like with the opposite sides of an equation, as long as you can do something to both the numerator and the denominator, it's allowed. It works within the laws of math. So in this case, I know that to move a decimal, I have to multiply the 2.5 times 10, and 5 is a factor of 10. So I'm going to turn this 5 into a 10 by multiplying it by 2. However, if I do it to the numerator, I also have to do it to the denominator. So essentially, I'm just multiplying this fraction times 1 in the form of 2 over 2. So I'm not changing the value, I'm just changing the proportion, making an equivalent fraction. So when I do that, I end up with 10, and I'm going to separate my 2.5 and my square root. 10 times 2.5 times the square root of 3 divided by 2. Sorry, that's 4. And then this simplifies one more time. 10 times 2.5 just makes it 25. It moves that decimal one place. So 25 square root of 3 divided by 4. not super pretty, but acceptable. But I better see something that looks like this. I don't want to have anything too crazy. I don't want to see decimals and square roots all together like that if possible. But this does, you can plug it into a calculator and it gives you 10.8 yards squared. And that is our final answer. I certainly have a clear idea of what 10.8 yards squared looks like than I would with just this guy. All right. That's kind of the same thing. Actually, this is as far as we made it in class. This is actually where I'm going to stop the video. It certainly covers all the important things you need to know and hopefully gives you enough practice with both the radicals and the Pythagorean theorem to be a little bit more comfortable with the concepts that we've been learning more in depth in this section. If you have any other questions, make sure you bring them to me either via email or in class next. Thanks so much. I'll see you guys later.